This video is about rates, ratios, proportions, and percents. So these are all very closely related and they're all very similar to each other. And we're not just going to talk about rates and then ratios and then proportions and then percents. We're just going to kind of lump them all together and talk about the idea of all of them all in one video. So the kinds of questions that we would be answering using these techniques is something like this. So at a local college, there are 500 students, and of those 500 students, 400 are residents of Massachusetts. So we might ask questions like, what fraction of the student body lives in Massachusetts? Or how many Massachusetts resident for each non-Massachusetts resident? Or what is the ratio of Massachusetts to non-Massachusetts residents? Or another school has the same ratio as this local college, but their student body is larger. Let's say it has 600 students. Same ratio, but more students. How many Massachusetts residents would we expect this school to have? So these are the types of questions that we would ask, right? Keeping the sort of proportion the same, talking about rates, talking about ratios. So let's just go ahead and answer all these. So let's start with the first one. So again, a local college, 500 students, 400 are residents of Massachusetts. And the question is, what fraction of the student body lives in Massachusetts? So there's some really key things here that we want to focus in on. So we've talked a lot in past units about how what you take a fraction of is very important. So if you'll notice here, we're taking a fraction of the student body. So that's the whole. And then within that whole, we are looking at those who live in Massachusetts. So remember, fractions are the number of pieces selected over the number of pieces in a whole. So here, the selected is the Massachusetts residents. That's who we're talking about, right? What fraction of the student body is what is Massachusetts residents? And the whole then is the number of students. And we got that from the fact that we said it's a fraction of the student body. So that's all of the students. So then we just set that up. So Massachusetts, there are 400 residents of Massachusetts. There are 500 students in the school. So this is the fraction of the school. So this is fine, or we might reduce it. Maybe we want to reduce it to 40 out of 50. Maybe we want to reduce it to 4 out of 5. Right? So the most common use of this type of information would probably get reduced to the 4/5. So we would say, 4/5 of this college student population lives in Massachusetts. Okay, so what about then the second question? So again, same college, same information. How many Massachusetts resident for each non-Massachusetts resident? So now I'm comparing Massachusetts residents to non-Massachusetts residents. So this is a little bit different from the question before, which was Massachusetts residents compared to the entire population. Here we have Massachusetts residents compared to non-Massachusetts residents. So the first thing we need to do is we need to figure out how many non-Massachusetts residents there are, because that number isn't actually given to us. So if there are 500 students and 400 of them live in Massachusetts, that means the rest of them don't. So that means there are 400 Massachusetts and 100 non-Massachusetts. So to find out how many for each, right, or per is often a more common mathematical term, non-Massachusetts residents, what we're going to do is we're going to think about equivalent fractions. So we're going to set up some sort of fraction. And then what we want to do is we really want to focus on the fact that it's for each or per non-Massachusetts residents. So we're going to start with Massachusetts to non-Massachusetts. So there are 400 Massachusetts students for every 100 non-Massachusetts students. So I know that vocabulary sounds a little bit awkward, but I want you to try to get comfortable with that, right? Because we're talking about something like for each. So one way to interpret this fraction is to say 400 Massachusetts residents for every 100 non-Massachusetts residents. So it's giving us the right idea, but it's not quite to the format that we want. The question is for each non-Massachusetts resident. In other words, how many Massachusetts residents for one non-Massachusetts resident? So we just need to change the form of this fraction. We just need to play with it a little bit, equivalent fractions, so that I only have one non-Massachusetts resident. In other words, I want an equivalent fraction that has a 1 in the denominator. Well, it's not too bad to do that here. If I just reduce this fraction, divide the top and the bottom by 100, I can see that there are 4 Massachusetts residents for every 1 non-Massachusetts resident. Or, we don't necessarily have to have the non-Massachusetts residents in the denominator. We very easily could have set it up as this next fraction is set up with the 100 non-Mass in the top and then the 400 Mass in the denominator. And again, we want for each non-Massachusetts resident. So we want the non-Massachusetts to go to 1. So again, I divide by 100 to reduce this fraction. I have 1 non-Massachusetts to 4 Massachusetts. So which one is in the numerator and which was in the denominator, it's not really important, okay? But what is important as we're looking at Massachusetts versus non-Massachusetts, and that we want for each non-Massachusetts, which means we want to find an equivalent fraction such that the non-Massachusetts is equal to 1. All right, so what about the third question? What's the ratio of Massachusetts to non-Massachusetts? So again, we're comparing the same things as we did before, Massachusetts and non-Massachusetts, and now we're going to talk about a ratio of these. So again, we're going to think about equivalent fractions, the same one we just thought of. 400 Massachusetts, 100 non-Massachusetts, and we can reduce that, or not reduce it, but here we're going to reduce it, so we're going to say 4 Massachusetts to 1 non-Massachusetts, or if we flip that over like we did before, we get the same thing. 1 non-Massachusetts resident to 4 Massachusetts residents. Now, the notation for ratios is often not written as a fraction, okay? It is often written with this colon, okay? So 400 divided by 100, or 400 hundredths, we would rewrite as 400 colon 100. Or we might just use the word 2. So 400 to 100, right? So there are 400 Massachusetts residents to 100 non-Massachusetts residents, okay? Or if we want to use the reduced form, okay, we might have a ratio that looks like 4 to 1. And we would read it as 4 to 1, even if we put the colon in the middle there. Okay, so another school has the same ratio. In other words, the same ratio of Massachusetts to non-Massachusetts, but their student body is 600. Okay, so now we want to know how many Massachusetts residents there are. So we need to start looking for connections. So 500 students versus 600 students, and 400 Massachusetts residents versus we're not sure how many Massachusetts residents. So those are the bits of information that we need to put together. So this is going to be our setup. Now this is technically called a proportion because you have a fraction equal to another fraction and one of the numerators or denominators is unknown. But essentially what we're doing is we're just going to play equivalent fractions again. So we're going to look at the local school. So the school that we know, the local college that had 500 and 400, we're going to put them into this first fraction. So that's the ratio of Massachusetts residents to total students. Okay, and then we're going to take the second school. So this is the other school. We know that there are 600 students and we're looking for how many Massachusetts residents. So they go in the second fraction, and we know that ratio has to stay consistent, needs to stay the same. Okay, so we need a way to solve these types of setups or these types of equations. So this is one way to do it, and this is how I do it. I like to start with my original. So I know that I have 400 in the numerator and 500 in the denominator, and I need to turn that denominator into a 600. Right? Again, notice up here I have 500, but what I want is I want 600. So I need to come up with a path or a series of steps that will get me to 600 in the denominator. So the first one is to take the 500 and turn it into 100. This is one path. There are tons of paths you can take, but this is one of them. So I can turn the 500 into 100. So I reduce the original fraction. I reduce this fraction by dividing by 5. So now I have 80 hundredths. But again, remember, the goal is I need to get to 600. Ooh, well, I'm at 100, so it's not going to be too bad to get to 600. So now I'm going to find an equivalent fraction. If I have 80 Massachusetts students for every 100 students at school, then I know I have 480 Massachusetts residents for every 600 students at school. And what I did is I just multiplied this by 6. I just scaled it up. If I know I have 80 for every 100, and I know I have 6 sets of those, then I have 6 80s. So what this is telling me is that I've kept the ratios the same, and my new school or the other school that has 600 students is going to have 480 Massachusetts residents. Okay, so try this one on your own. So a town has 2 voting districts. In other words, the town has been sort of split into 2 chunks so that one group of people vote at one location, another group of people vote at another location. Right? These are often called wards. So we're going to talk about District 1 and District 2. So the ratio of voters in District 1 to District 2 is 10 to 11. So that's the information that you're given. The ratio of voters in District 1 to District 2 is 1 to 11. Using only that information, I want you to try to answer these next 4 questions. So really, I want you to pause this video. I want you to try to answer those 4 questions. See how you do. The answers are going to be on the following slides and in the rest of the video, but I want to make sure that you understand what's happening. So pause this video, go back a little bit, read those questions, do them, and then we'll go over them to see where we are. Okay, so first you need to find the ratio of District 1 to the town. So we need to figure out what the town won. So District 1 was 10 and District 2 was 11, and you were told there were only 2 voting districts. So that takes care of the entire town. Well, for every 10 people in District 1, there are 11 people in District 2, which means for every 10 people in District 1, there are 21 in the town. Now, if there were 3 voting districts or 4 voting districts, then you wouldn't have enough information to answer this question. But because there are only 2 voting districts, you know that there are 10 in the first for every 11 in the second, which means there are 10 in the first for 21 in the town. Okay, so if there are 8,400 voters, how many live in District 1? So now we're comparing the town to District 1. So that is going to be our setup. So in your equation, you need to have District 1 and you need to have the town. Now, if you flip those over and you put the town on the top and District 1 on the bottom, that is totally fine. That definitely works. Okay. And here's where I'm going to start sort of reiterating this idea of labeling what your numbers are and what they represent is really, really helpful. So notice in the examples that I did before, I labeled absolutely everything. So it might be nice for you to start to get in the habit of labeling. Labeling will eliminate some very common errors. And for me, it helps me keep track of what I'm doing and what those numbers were to begin with. So we have District 1 and we have the town. So my original fraction is 10 in District 1, 21 in the town, but I need to scale this up to get a total of 8,400 voters in the town. So for me, I needed to turn that 21, I need to scale it up to 8,400. So you need to come up with a path that works for you. So this is one that I saw. So I can turn 21 into 84 by multiplying by 4. So that means my 10 became a 40. And then I can turn 84 into 8,400 by multiplying by 100, multiplying by 100. So I have an equivalent fraction that tells me that 10 over 21 is the same as 4,000 over 8,400. So how many voters live in District 1? 4,000. What fraction of the town voters live in District 2? So now I have District 2. So District 2 was the 11. So there's my District 2 as 11. And then I needed to compare it to the town. So just like we mentioned in A, and then we also used in B, that if District 1 is 10, District 2 is 11, and those are the only 2 districts, then the town is 21. So that's where this number is coming from. So that's District 2 relative to the town. And any fraction equivalent to that fraction shows District 2 relative to the town. And then this last one, we're looking at how many voters in District 1 per voter in District 2. So we're starting with the two numbers we're looking for. We're looking at District 1 and District 2. So going back to the original ratio, we had District 1 to District 2. So that's my setup. So D1 over D2. Again, if you switch those, that's fine. So District 1 had 10, District 2 had 11, and then looking carefully at the question, it says how many voters in District 1 per voter in District 2, which implies only one. So per one voter in District 2. So what we need to do then is we need to find an equivalent fraction that has a 1 in the District 2 spot. So I followed the pattern of taking the numerator and dividing by 11 and taking the denominator and dividing by 11. And I chose 11 on purpose because that turns the denominator into a 1. So therefore District 2 lines up with 1, and then District 1 is going to line up with this 0.90 repeating. It actually goes on forever. So we're just going to round that off. So how many voters in District 1 per voter in District 2? About 9/10, or a little bit more. Okay, so let's talk a little bit about percents. So some of you are going to be really comfortable with percents, and some of you are going to struggle with these, as with any topic in this course, right? So let's talk a little bit about what percents are, and then hopefully that will help us. So first, a little breakdown of the word percent. If I take percent and I break it up into percent, just put a space in the middle. Cent in the English language, the prefix cent is often represents 100. So there are 100 cents in a dollar. There are 100 years in a century. It was originally thought that there were 100 legs on a centipede. It doesn't always mean 100, but it's a very common prefix to mean 100. So the word percent comes from the literal meaning per 100. So the first question that we have to ask, just like with fractions, just like with the ratios and the rates, is 100 what? In other words, what are we taking a percentage of? So just like with fractions, what are you taking a fraction of? What are we taking a percentage of? That number is our per 100 number. So for example, what percentage of this class has taken an online class before? So we need to read this question very carefully to figure out what we are taking a percentage of. So in this case, we're taking a percentage of this class. Okay, out of that group then, who are we talking about? We're talking about taken an online class before. So those are sort of my two groups. I'm taking a percentage of the class, so that's my whole, that's my 100, and then out of that I want to know the online course. So let's just say I made these numbers up. Let's say this class has 25 students in it, and 4 of them have taken an online class before. Well, this is not a percentage because my percentage of this class is 25, not 100. So I need to use equivalent fractions to either scale it up or scale it down to get to 100. Now I chose 25, so it's kind of nice. I can scale that up to 100. So I multiply by 4. I end up with 4 25ths is equivalent to 16 hundredths. Therefore, it's 16%. I'm going to show you really quickly here sort of where that little symbol came from. So 16 over 100 is the same. I can rewrite it as division sort of on its side. So 16 divided by 100. And then at some point in our history, we dropped the 1. So we did 16 divided by 0, 0 implied that we were dividing by 100. And then I'm not sure this happened, but it's kind of cool. One of these zeros just sort of popped to the other side of the line. And that gave us our current percent sign. What I like about the current percent sign is there's actually a 100 right there. There's a 1, 0, 0. Okay, you kind of got to stretch a little bit to see that. But the fact that a percent sign looks like a 100, looks like kind of like a 100, is extremely helpful in helping us remember what a percent is. So literally, the symbol that we're used to, this little percentage symbol, it literally means divided by 100. So percent symbol is the same as divided by 100. And we're going to use that a lot when we talk about percentages. So let's go back to the college example. So again, the local college, there are 500 students, 400 are residents of Massachusetts. So let's do a percentage question. Let's say, what percentage of the college are non-Massachusetts residents? So we're focusing on percentage of the college. So we're looking at all 500 students. And out of that group, we're looking at the non-Massachusetts residents. So if there are 500 students, 400 live in Mass, that means that 100 are non-Massachusetts residents. So let's set up the original fraction. So I want non-Massachusetts, that's my 100, relative to the school, that's 500. If you flip that over and have the school on the top, that's fine. Just remember that the school is what is going to 500, right? All of the students, because we're taking a percentage of the college, so all of the college students. So currently it's at 500. We need to turn it into 100. That's not too bad. Reduced by a factor of 5. So that gives me 20 over 100. So here I divided by 5. I divided by 5. So 20 over 100. 20 over 100 is 20% over 100%. Okay. So again, let's do one maybe where it's not so easy to get to 100. So now I have 37% of Massachusetts residents have been lifelong Massachusetts residents. How many of the students have been lifelong residents? This is one we might want to read again. And let's do some underlining. So 37% of Massachusetts residents. So I'm finding a percentage of the Massachusetts residents. And again, we're looking at the college, right? We're not talking about all Massachusetts residents, but for this college, 37% of those Massachusetts residents have actually been lifelong Massachusetts residents. So they've lived here forever. How many of the students have been lifelong residents? Okay, so the whole, the total, that is our Massachusetts residents. Out of that, we're looking at lifelong Massachusetts residents. So notice, we're not using the school as a whole at all here. We are finding a percentage of Massachusetts residents. That's my whole. That is the one that goes with the 100. Out of that group, we're talking about lifelong Massachusetts residents. So our two labels, you can see where labels might become pretty important on a question like this. We're labeling lifelong Massachusetts and we're labeling current Massachusetts. Okay, so the lifelong is going to go with the 37 of the 37%. The current Massachusetts residents, that's going to go with 100. So that's my percentage. So notice this time I gave you the percent and you're solving for something in the other fraction. The setup is the same. Don't freak out. It's the same kind of question. So 37%, it means 37 divided by 100. The 100 goes with Massachusetts residents, so it's the current Massachusetts residents at this school. Then the 37 goes with the part that you're looking at, what you've selected. So we've selected the lifelong Massachusetts out of the current Massachusetts. So there's my 3,700. So then I need to fill out one of the other numbers on the other side. Well, I don't know in this college the lifelong Massachusetts. I don't know that. That's my question mark. So I better know the current Massachusetts. Current Massachusetts, I do know. Current Massachusetts, 400. 400 are residents of Massachusetts, given to me in the question. So here's my setup. 37 over 100 equals what over 400? So again, we're just playing equivalent fractions. So I'm going to do it in 2 steps. You can do it in 1. It's up to you. 37 hundredths. If I multiply by 2, I get 74 200ths. If I multiply by 2 again, I get 148 400ths. So what is this telling me? Just look at your labels. If there are 400 Massachusetts residents, then there are 148 lifelong Massachusetts residents currently at this school. All right, back to the voting example. So again, the town has 2 voting districts. The ratio of voters in District 1 to District 2 is 10 to 11. So then the question is, what percentage of the town votes in District 1? So we're comparing District 1 to the town. So remember, District 1 was 10, District 2 was 11. Since there are only 2 districts, it means the town is 21. My setup. Okay, now, I like this example, and I saved this example because I know some of you in the back of your heads are being like, oh, you've picked all these easy numbers. It's easy to turn 500 into 100. It's easy to turn 25 into 100. So what if you have a situation like this where it's not easy to turn the denominator into 100? 21? Not really easy to turn that into 100. So this is going to be one method that you can use to get that denominator to 21. So again, I'm doing District 1 to town. So District 1 has 10, town has 21. So I have 1021, and I need to turn that into a percentage. So I need the town to be 100. And I know that because I'm taking a percentage of the town. So of the town is telling me I want that number to be my per 100. So here's what I do. So I start with my 1021, and I divide the numerator and the denominator by 21. Now, why would I do that? I do that because it turns my denominator into 1. And once that denominator turns into 1, I can turn it into any number I want, right? So if I divide the numerator and the denominator by 21, I turn this into a fraction over 1. Now notice that numerator might be really small, might be decimals. I don't care. Decimals inside of fractions are totally fine. Now I can turn that 1 in the denominator into 100 by multiplying by 100. So there's my 47 and 62/100 over 100. And then again, I'm done as far as finding a percentage because that dividing by 100 is the same as the symbol per percentage. So dividing by 100 is what this symbol means. So I don't have to do anymore. Now, those of you who have learned another way to do this, you're looking at this and you're saying, oh, why would I do it that way? Just take 10 divided by 21 and multiply it by 100. Or take 10 divided by 21 and shift the decimals. That is exactly what we did here. It's exactly what we did. We just did it inside of something we already knew. So rather than memorizing a new idea or learning a new process, we're just playing with equivalent fractions, something that we've done a bunch in this class, right? I took my 10 over 21, I divided the top and the bottom by 21. That gave me a new fraction with a denominator of 1, and then I multiplied the top and the bottom by 100. That gave me my 47 and 62/100%. Okay, so last thing we want to talk about in this video is percent increase and percent decrease. So this is used to show how much a value has changed relative to its original size. So why might this be important? So here's kind of an exaggerated example. If I add 2 feet of height to a 4-foot fence, so in other words, it became from a 4-foot fence, it became a 6-foot fence. Well, adding 2 feet to that fence is much more dramatic than adding 2 feet to a building that's 30,937 feet tall. So it went from 30,937 up to 30,939. Now, in both situations, the increase was 2 feet, but 2 feet added to a 4-foot fence is much more influential, much more dramatic than adding 2 feet to a huge building. So percent increase and decrease allow us to capture that idea of, okay, great, you added 2 feet. Was that a lot or was that a little? So here's how we do it with the fence. So the key to percent increase and percent decrease is it's always a percentage of the original, the starting number, what it was before it increased or before it decreased. So in this case, the fence was 4 feet high and then 2 feet was added on top. So it's the original number. If you're talking about time, it's the earlier number. Okay, so I have the change. So that was 2 feet over the original. That was 4 feet. And now I need to turn this into a percentage by making the original be 100. So make that denominator be 100. So There are several ways to do that. Here's one. So I divided the numerator and the denominator by 4. So I'm showing you the method that sort of always works. So I divided the numerator and denominator by 4, so I got a half over 1. And then I multiplied by 100, so that gave me 50 over 100, which is 50%. Some of you could have skipped all of the work and just said right off the bat that 2 is 50% of 4, and that's fine. Okay. Some of you are going to need a couple more steps in the middle, and some of you might have used totally different steps. All of that is fine. Okay, now for the building, the change is 2. The original was 30,937, so I need to turn that into a percentage. I need the original to become 100. So I divided the top and the bottom by 30,937. So I divided by 30,937. And I did that to the numerator as well. And so I got this little decimal on the top, which is no surprise. I took 2 and divided it by almost 31,000. Right? So I divided by a very, very large number. And so I have a fraction and multiply by 100. And so now I end up with this. And if I look in that numerator, that's a pretty small percentage. Now notice, I just want to point this out again. This numerator is exactly the same number that I have written right here. Okay? The dividing by 100 just becomes a percentage sign. I don't actually do it. Okay? Now, within this question, right, my percent increase and decrease, it very clearly shows that, whoa, adding 2 feet to a 4-foot fence is much more dramatic than adding 2 feet to a 31,000-foot building. Now, this is a very exaggerated example. Obviously, it's very clear that adding 2 feet to 4 feet is much more significant than adding 2 feet to 31,000 feet. But there are examples where it's not so clear. Okay, so I added 1 foot to a 4-foot fence, or I added 10,000 feet to a 30,000-foot building. That one might be a little bit more complicated. We might have to do a little bit more work for it. So this is just an exaggerated example to show you percent increase and decrease are nice because they talk about the increase relative to the original number. Now, sometimes just the increase is enough information. Sometimes just the percent increase is enough information. And a lot of times both of those put together gives the most information. Okay, so in summary, in context problems, I cannot stress this enough. Label, 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 label. Label what the number in the numerator means. Label what the number in the denominator means. Label, label, label. It will help you keep things straight. 2, percent means per 100. So use equivalent fractions. You already know how to do that. So figure out what you're taking a percentage of. That is what you want to turn into 100. And then the symbols. So the percentage literally means divided by 100. Literally means divided by 100. Percent increase and percent decrease. You're going to take the change. So how much it increased or how much it decreased, and you're going to put that over the original number, the earlier number, the number that it was before the increase or decrease.